Hello, Jahur Bhatt. Welcome
Yes,
to
sir.
the
Good afternoon, sir.
Good afternoon. Am I audible to you?
I am fine, sir.
Okay. So just give you a brief intro about yourself.
Yes, sir. My name is Zuhur Ahmed Bhatt. I am from Jammu and Kashmir. I did my basic schooling from my native district. After that, I completed my B.Tech in mechanical engineering from Chandigarh Group of Colleges, which is affiliated to Punjab Technical University. And I recently completed my master's in thermal science and energy system engineering from Indian Institute of Technology, Jammu. And during, I have worked on a project on heat transfer study through mini and micro channels, in which I work on the different designs of the channel to enhance the heat transfer performance. And I have also participated in a conference has been conducted by the National Institute of Technology, Calicut, where I have presented a paper. And apart from the academic curriculum, my hobbies are playing cricket and surfing on the internet.
Okay, Jahur Bhatt. So you are qualified for which examination? Exam you
Sir,
want to give?
sir, JKPSC Assistant Engineer Mechanical.
Okay. So what's your interview date?
Sir, interview date is yet to come, sir. They have not announced yet.
Not notified, है ना? It may be
Yes, sir.
soon in the
Yes,
month
sir.
of March or April,
Yes,
है
sir.
ना?
In the
Okay.
month.
So just tell me what are the various assumptions under the banding question?
Yes, sir.
Can you just tell me what are the various assumptions in the banding question?
Banding equation, sir.
Yes.
Yes, sir. Sir, in banding equation, the first assumption is the cross section of the beam should be prismatic. That there should be uniform cross section. The material of the beam should be homogeneous and isotropic, and only the pure bending is applied on the beam. And the planes which are and the surfaces which are plane before bending should remain plane after the bending as well.
Is there any assumption like the homogeneous and isotropic?
Yes, sir. The material should be homogeneous and isotropic in case
What's
of
it mean? What do
bending.
you mean by homogeneous and isotropic?
So usually, sir, if we talk about the isotropic, means the properties does not change in with respect to direction, and at a point, and in homogeneous, the properties remain constant in a particular direction with respect to point. That means the properties remain homogeneous, uniform in all the directions.
What do you mean by creep?
So the creep is basically a slow deformation that is usually seen at the higher temperature when a certain part is under the constant load very for longer time, and due to the change in the temperature, there occurs a deformation in that product that is known as creep.
Okay. What do you mean by fatigue load?
Fatigue load is it is basically when a component is loaded in such a way that the load changes either it is magnitude or its direction or both magnitude direction. In that case, the failure occurs is known as the fatigue failure.
Endurance limit?
Endurance limit is that limit up to which a material can sustain the fatigue failure. Beyond the endurance limit, the material undergoes fatigue failure.
Okay. So can you just tell me what are the various points in the stress strain curve for a mild state?
Yes, sir. So first point is the proportional point. It is that point after which the stress and strain relationship remain linear. And after the proportional limit, there is the elastic limit. It is that point after which the material behaves perfect elastic. And then we have this upper yielding and lower yield point. These are the point below which at which the material starts going under the plastic deformation. Then we have the strain hardening zone, and after that we have this ultimate tensile stress point, where the maximum stress is obtained in stress strain diagram, and beyond the ultimate tensile there is a fracture stress at which the fracture takes place.
Okay. Can you just differentiate between the upper yield point and lower yield point? What is the
Yes, sir.
basic
Sir,
difference?
as well. So, sir, as up to the elastic point, as you seen, the material behaves perfectly elastic. But if further applying the load, the material changes its behavior from elastic to undergo into the plastic zone. Sir, in that that is the upper yield point, and beyond the upper yield point, there is seen that there is increment in the this strain, but the load decreases up to some point. That is up to lower yield point, and at lower yield point, the stress which you are actually applying on the with the stress that we are applying for the continuous to continue the plastic deformation, that is the lower yield point.
Okay. What do you mean by strain hardening?
So strain hardening is basically when it is that phenomena in which the strength of the material increases due to the uh, when we apply the external load when the material goes from elastic to plastic deformation. After that, there is a certain increase in the strength of the material. So that increase in the strength of the material is known as strain hardening. It is due to the blockage of the dislocation is that present inside the material.
Okay. What do you mean by modulus of resilience?
Modulus of resilience. Sir, modulus of resilience is basically is defined as the proof resilience per unit volume. It actually represents the amount of energy that a material. It is the amount of energy that a material absorbs per unit volume up to the elastic point per unit volume after the elastic point.
और क्या कहते हैं आपका proof resilience क्या होता है?
Please, sir, can you repeat, sir?
What do you mean by proof resilience?
Proof resilience. So the proof resilience is the energy, maximum energy that absorbed by the material up to the elastic point. It can be obtained from the load versus deformation diagram.
What do you mean by toughness?
Toughness is the maximum amount of energy that a material absorbs or sustains after the fracture.
What do you mean by statically determined member?
Sorry, sir.
What do you mean by statically determined member?
Statically determined. Yes, sir. Sir, if a beam or if a structure load in such a way that the number of unknowns can be obtained from the number of given statically indeterminate or determinate. Sorry, sir.
Determinate बता दो.
Determinate. Yes, sir. If the number of unknowns is equal to number of useful equations, that number is called as statically determinate number.
Okay. So what types of support we are just using in the case of a simply supported beam?
Sir, we are using this roller support is there. There is fixed support and there is this hinge support. Sorry, sir. This fixed support, roller support, fixed support, and one is I'm just forgetting the name, sir.
Hinge support.
Yes, sir.
I'm just asking in the case of simply supported, what type of supports we are using mainly, generally?
Yes, usually in case of simply support, we are using the hinge along with the roller support.
Why only that?
Because, sir, in that case, we are usually getting the determinate condition of the beam. Like in that case, we are obtaining the three useful equations. And sometime when the beam is loaded and there may be some so the horizontal reaction component the beam can be allowed to move in the horizontal direction a little bit because there is a roller support at one end. So in that case, we are not getting the horizontal reaction at that support.
Okay. So, Jahur, but overall, you are a good days knowledge teacher and you have a good knowledge about the subject also. है ना?
Yes, sir.
आपकी subjective knowledge अच्छी है, कोई ऐसा issue मुझे लगा नहीं जितने क्वेश्चन मैंने पूछे आपने to the point आंसर दिए, ज़्यादा घुमाया भी नहीं और सही तरह से आंसर दिए. So I think it's good for you. कभी आपका जब इंटरव्यू डेट आ जाए तो एक बार फाइनल इंटरव्यू और देना जिसमें आपको थोड़ा सा लेवल अप करके पूछा जाएगा.
Sorry for the disturbance.
No. Thank you for doing it.
Thank you.